So this is a video on if you have categorical data, right? This is data where one of your variables is a word, right? So here, one of my variables is Brazil, Argentina. I think most of you are in here. So very first thing, a couple of things about this data sheet. You might notice I have a trial number here. This is just to help me keep track of like data points and make sure it's a little bit easier for me to navigate, right? So that way I don't get lost as much. You also might notice that here, right, two things about this thing here. One, you might notice that I have a unit, right, after the thing in parentheses. You should have this, right? So this is COVID cases per 1,000 people, right? So it's saying in, this area here, right, in trial 2 in Brazil, this is made up data, right? There are 730 COVID cases per 1,000 people, right? So that unit is very helpful, right? Because there's a big difference between 730 cases total and 730 per 1,000 people. You also might notice that because of how long this is, it kind of goes over the cell into the other ones. An easy way to fix this is to go here between C and D and just double click, and it will automatically expand to kind of easily fit that. Right. So here I have all my data. I got a category and numbers. Right. So the very first thing you need to do before you do any sort of other data analysis is find the skew of each one. Skew, right, and then highlight the data for Brazil. You don't need the words, just the numbers. Right, and there's the skew. Right, the negative, positive do not matter. What matters is the amount. Right, in general, you want let me get into Argentina before we talk about why. So skew, right, highlight Argentina, and we're done. Okay, so again, Excel's pretty good on this. Okay, so the reason for the skew is that the skew tells us kind of what sort of like data analysis we're going to do. If your skew is, the absolute value of your skew is between 0 and 0.5, right? So I have that, right? You'll be doing, right, average and standard deviation. If my skew was greater than, the absolute value of my skew is greater than 5, I would instead do median and interquartile range, right? Because median is a little bit better at not counting outliers. Okay, now let's do the data analysis for this real quick. Let's do average, right? Real quick right here of that. And standard deviation is equals stdev.p. And right here. Okay, so for formatting, you might notice that all these kind of have different number of decimals. What you can do, especially for like the average and standard deviation, is highlight them and right click and go to format cells. Okay, make sure you're on the number tab over here, and then you can just make them a number and then like change it to like 1 or 2 decimal places. Right, that way it's just consistent and a little bit easier to read. Okay, same with Argentina. My absolute value is between 0 and 0.5, so I'm going to do average and standard deviation. Same formulas, right, equals average. Just instead of Brazil data, I'm going to highlight all the Argentina data, not just 2 numbers. Okay, well, I'm just typing this to make sure y'all are listening. If you message me potato, I will give you guys extra credit. Or potato, I don't know, it's a word. So now I have my data for each of them. If I want, I might move these a little bit closer together. I have them a little bit next to their own things just to make it a little bit easier. Oh, and change the formulas because it's formula based. So now I'll just keep them together from there. So once you got this done, this is kind of a lot of what your data analysis is going to be about. So you got to do a couple things after this. First of all, you need to make graphs. The graphs, probably the easiest one to do would just be one comparing the averages of the two. Right, to do that, you're going to go to insert, and that will be a bar graph. Okay, you might notice this bar graph is blank. That's because I haven't given it any data, because Excel gets really weird about highlighting data like this. So we're going to select data, add an entry, we'll call this entry name Brazil average, and the value, you will delete everything here and just click the average. Okay, you'll repeat that for every category you have. For me, that's the next category is Argentina. Same thing, just delete the 1. There we go. Okay. So here's our graph. It is not done. So a couple things. If you want to add elements to the graph, that is the plus button here. Right, so we're going to need a chart title and axis title, and we're going to get to error bars in a second, and also a legend is probably useful. Okay, chart title doesn't have to be anything inventive. This would be like average COVID cases per 1,000 people. Right. No need to be pithy or clever here. Science is supposed to be functional, not nice. You can delete the bottom axis here, because right, that's our key, so you can delete this 1. Just backspace it. Same with this axis title here. Just highlight the thing and just, there you go. This is, right, okay. Right, so this I can kind of tell what everything's going on. There's one last thing you need for your graph, though, right? You're going to go to here, you need to add error bars. That's why we calculated our standard deviation or IQR. Right, so we're going to go to more options here. Okay, you'll have to do this first, so it doesn't really matter. So we'll start with Brazil average, right? And you'll see this little bar here. These are error bars. These are kind of showing, hey, our average is here, but based on the deviation, right, there's a good chance it's somewhere between here. So we're going to go custom and specify value. Delete both the positive and negative error values. And right, we're going to put standard deviation and standard deviation. Cool. All right, click off that. Repeat again, the whole thing, more options for Argentina. Custom, specify value, delete, positive is that, negative is that, okay. All right, so there's the main graph you need, right? You can see the error bars, it's all kind of there, right? You will eventually copy and paste this onto your Word document. For now, you can leave it here. If you wanted to, you could also highlight the whole data for Brazil and put in like a histogram if you want. In general, the more data, the better, right? So the more graphs you can put in, the better. Just make sure everyone has a title and any sort of access labels, and right, be ready to kind of mess around with it. The last thing you need, right, before you're done, is a p-value, basically saying, hey, is there a significant difference between Brazil and Argentina, right? Is there an actual difference here? You don't have to do this in Excel, right? You can just Google it. So we're going to go over here to new tab, and for this is a t-test calculator. If your skew was high, if it's above 0.5, instead you'll do a Wilcoxon rank sum calculator. All right, so t-test for median, t-test for average and standard deviation, Wilcoxon for others. And if you have 3 or more categories, that's ANOVA, right? So this part kind of depends on your thing. If you have 3 or more, it's ANOVA. If you have 2, but the skew is high, it's Wilcoxon. If you have 2 and the skew is low, like I have currently, it is t-test. I prefer social science statistics because what I know. Let's go here. Please note, once you go to the actual calculator here, this is something you have to cite as a source, right? Because it's a source you're using, right? But beyond that, right, you just go to your data, copy treatment 1, which in this case is Brazil. Just copy and paste that in. Same with treatment 2, which for us is Argentina. Just copy and paste that in. Okay. Leave it at 0.5, leave it at one-tailed, and calculate. Okay. Here's all the math. If you want to take this, right, and I would take a screenshot of this here, right, for like your kind of calculation section. Be like, here's the math it did. But here's the important part. Okay, is it gives us a p-value, right? Again, the p-value tells us if there's actually a significant here, because sometimes the human brain likes to see patterns where there are none. So the p-value actually says, hey, is this actual random chance, or is it actually something happening? If the p-value is less than 0.5, which is our significance level, right, then we can say, hey, something's happening here. So based on my p-value of 0.01, I'd copy and paste this or take a screenshot of this and put it in my Excel sheet. Right, wrong one. I'd be like, p-value. Okay. And then based on that p-value, right, we can say, cool, it's significant. The other two work the same, right? Where you just kind of go to calculator, make sure you're citing these, put one data here, put one data here, right? And just click calculate. You can kind of leave significance level and the hypotheses on their own. And ANOVA, I believe we actually did this, right? Same thing, just you can put up to 5 treatments, which means you'll actually have an overall p-value and a p-value between each different treatment. Okay. So hopefully that, right? And once you got a p-value, a couple graphs, and some measurements of central tendency, you're done. So hopefully this is helpful, and hopefully it gets into YouTube in time for class.